In this video, we are going to calculate the costs and QALYs for treatment A. If you recall in the previous task, in task 1, we entered a number of input parameters onto the input sheet. We had the transition probabilities for treatment A. We had the relative risks for treatment B. We had the transition probabilities for treatment B, which we calculated based off the transition probabilities for treatment A and those relative risks. We then entered some costs. There were costs for each treatment, A and B, and there were other healthcare costs, which varied by state. And then finally, we entered the health utilities, which also varied by state. And in this task, we're going to use all of these input parameters to calculate the costs and the QALYs for treatment A. And then in task 3, we'll do the same thing for treatment B. So what's the first step in task 2? Step 2.1, enter the cycle length and time horizon on the settings sheet. So the settings sheet has now appeared. And right now there are two settings that we can see. There are cycles per year and total cycles. And what we're told is that there will be a monthly cycle length and a 5-year time horizon. So a monthly cycle length means there are 12 cycles per year. So we enter that one first. And it does say here that it may take longer than usual for the spreadsheet to recalculate after entering these settings. And you can see up here the bar showing us the recalculation. So just a few seconds longer than normal. And then in H20, we need the total cycles. Well, we have 12 cycles per year and the time horizon is 5 years. So 12 times 5 is 60. Okay, so that's 2.1 complete. And now step 2.2 has appeared. Construct the transition matrix for treatment A. And to do that, we need to go onto the model sheet that has now appeared. So on this model sheet, we're going to construct our Markov model, given the settings and the input parameters that we've entered on the previous sheets. And we're going to do this first for treatment A and then separately for treatment B. And the first step is to calculate this transition matrix. So in the transition matrix, we have all the probabilities that we entered onto the input sheet, but we're going to put them together in this matrix. So we have the initial state, let's say asymptomatic, and then the next state, which might be asymptomatic again. What's the probability of going from asymptomatic to asymptomatic? What's the probability of going from asymptomatic to mild? And so on and so forth. We need to complete this. And this is quite straightforward. We just need to reference those transition probabilities for treatment A on the input sheet. It's very important that we reference the values on the input sheet and that we don't just hard code the values that we entered back in task 1. We should not do that. If you hard code these probabilities, by which I mean you just enter 0.91, which I believe was the transition probability for asymptomatic to asymptomatic. If you just type in 0.91, that is the correct value right now. However, later in the exercise, when we make the model probabilistic, every time the model recalculates, there will be a different transition probability. And if we've hard-coded it on the model sheet, well, then that correct transition probability will not be propagated through the model. So it's very, very important that we use a formula here. So equals. And if we go to our input sheet, you can find right here D24. And you can see it up here, the formula now says equals inputs and then an exclamation mark D24. And then without clicking anything else, just press enter and it will take us back to the model sheet with that formula equals inputs D24. Now there's another way of doing this, which is to use the named ranges. So if I just go back to the input sheet for a moment, you can see that this transition probability from asymptomatic to mild has been given an assigned name, which you can see in the name box here. And I've also repeated it just here in E23. So P underscore asymp underscore mild A. So that's the probability of going from asymptomatic to mild with treatment A. That's how you interpret this. So what I'm going to do is I'm just going to right click and copy that. And then I'm going to go onto the model sheet, and here, which is, the initial state is asymptomatic, the next state is mild, so it needs to go here. I'm going to put equals, and I'm going to right click, and I'm going to paste that named range and press enter. And this is entirely equivalent to referencing that cell on the input sheet, which is what we did here. So two different but entirely valid ways of referencing those probabilities. Let's do the next one, which is asymptomatic to severe. So I'm going to click there. I'm going to go to the input sheet, click on severe, press enter, and then finally dead. And this takes a couple of minutes to do this step, but it's a very, very important step. So asymptomatic to dead. And then the next one we need starting in mild and going to asymptomatic. So go to inputs, I'm going to scroll along a little bit. Mild to asymptomatic is that one. Then we need mild to mild. Then we need mild to severe. Then we need mild to dead. Then we're going to do severe to asymptomatic. Again, I'm going to scroll along a little bit further. So severe to asymptomatic is this one. Now these are just 0, so you could hard code 0 for these, but at least in principle, it's always better to reference the input sheet. What if you were to change that assumption? And I've made a mistake there. So that equals, there we go. So yeah, I made a mistake in how I typed it in and it marked it as wrong. And then I corrected it and now it's right. So yeah, in principle, what if you changed that assumption that you cannot return to the asymptomatic or the mild state? If you were to change that assumption, you would of course update your input sheet, and it's good practice for your transition matrix to just, I've done it again, to just reference your input sheet. So I don't know why I keep doing that. Let's see if I do it correctly now. So severe to dead. There we go. And then finally, from the dead state, we don't have those on the input sheet because by definition, once you're dead, there is 0 probability of moving to any other state. And that's not going to change even in the wildest sensitivity analysis. We're not going to have people coming back from the dead. So we can just hard code this as 0, 0, 0. And then the probability of starting a month in the dead state and finishing it in the dead state is 1. Okay, so that's the transition matrix completed for treatment A. So step 2.2 is complete. And then before we continue, we're going to do a validity check. Now, in this exercise, because everything you enter is being marked in real time, we know that everything you've done is correct at this point. But if you were building this model yourself, then it's possible that you've made a mistake. And one way of checking for that is to see whether these values sum to 1. You can see I've just highlighted them and you can see sum 1 down in the bottom. If these did not sum to 1, well then you know that you've made a mistake. I guess it's possible that they would sum to 1 and you've made a mistake, but it's one way of proving that you have made a mistake if they don't sum to 1. And if they sum to 1, then it's probably correct. So we can do a validity check. So we can do equals, and there's various ways of doing this. You could do this plus this plus this plus this. You could use the sum function. I'm going to use the sum function. So sum, and then open a bracket, select all of these, and then close the bracket. And it's checking that this formula is valid. It copies it across and it's got the correct value in every cell. So it's happy with that formula. Okay, let's now move on to the sample path. And the sample path calculates the probability, or I should say the proportion of that cohorts that are in each state on each cycle. So any given cycle, what is the proportion that is in the asymptomatic state? What's the proportion in the mild state, and so on? Now, at the very beginning, the assumption is that every patient is asymptomatic. So in cycle 1 here, the very first cycle, we're going to say that the proportion of 100% of the cycle, of the cohort, I should say, are in state asymptomatic in cycle 1. And for the others, it's going to be 0. So 0 in mild and 0 in severe. I'll just wait for those to be marked. I always like to make sure that everything is being marked correctly before I do the very last cell with any given step. And dead is also 0. Okay, so that's step 2.4 complete. And in step 2.5, we're now going to move on to cycle 2. And this is where things get complicated. We can no longer just put in a hard-coded 1, 0, 0, 0. We need a formula to calculate what the proportion is in not just cycle 2. This formula is going to be copied across to 3, 4, 5, and 6. And it's also going to be copied down to the mild state, the severe state, and the dead state. So we need to think about a formula that would work for all of these cycles and for all of these states. Okay, so one way of thinking about this is, how can I end up in the asymptomatic state? Okay, so for the asymptomatic state, you can get there by either starting the previous cycle in the asymptomatic state and then remaining asymptomatic. Or maybe you could start the previous cycle in the mild state. This is not valid for this cycle because there aren't any, but later on, let's say you were here, you're talking about cycle 3. Well, in cycle 2, there will be some patients who are mild. They could move to the asymptomatic in cycle 3. That's possible. No one can move from severe to asymptomatic or dead to asymptomatic. But what about, say, the mild state on cycle 3? How could you end up there? Well, you could be asymptomatic on cycle 2 and then move to mild, or you could be mild on cycle 2 and stay as mild. And what about the severe state on cycle 3? Well, you could get there from asymptomatic or from mild or from severe. And dead you can get to from any of the other 3 states, and of course people who are already dead will remain dead. So we need a formula that considers all of the 4 states where people were on the previous cycle, and all of the probabilities of moving to the asymptomatic state, in this case, on the next cycle. So it's not straightforward. So you also need to think very carefully about the dollar symbols which we use to differentiate between absolute cell references and relative cell references. And I'll let you read just on the left here. There's a long paragraph here about how you use them, so I'll let you read that in your own time. But let's get started with this. So one way of doing this would be to say that the probability of ending up in this is, if you were asymptomatic on the previous cycle, and then we would multiply that by the probability of going from asymptomatic to asymptomatic, which is this one here. And then I'm going to add the probability that you started the previous cycle in mild, and we're going to multiply that by the probability of going from mild to asymptomatic, which is this one. Then I'm going to add the proportion that were in the severe state on the previous cycle and multiply it by the probability of going from severe to asymptomatic. And then finally, I'm going to add the proportion that were dead and multiply that by the probability of going from dead to asymptomatic. You might think, well, why would you do that? That's redundant. It's clearly 0. Well, this formula will be copied down to all of the states, including dead. And once when we're talking about moving to dead state, then yes, we absolutely do need to have that probability of going from dead to dead. Now, before I press enter, is this going to work? Once it gets copied across to the right and down? And the answer is no, this isn't going to work because I have not used any absolute cell references. Once this gets copied across, it's going to give all sorts of errors. So we need to put some dollar symbols in. Now let's think about this. When this gets copied down, I don't want the D40 cell, I don't want that to change to D41. So I want the 40 in D40 to remain as a 40. And that same logic applies to the 41 and the 42 and the 43. Now, do I want the D to remain as D when I copy this across? No, I don't actually. When I copy this across to cycle 3, well, instead of referencing D, I want it to reference E. So actually, I'm not going to lock any of the Ds. Now, the next thing is when this gets copied across to the right, do I want that reference to E23 to also move across to the right. The problem with these 4 cells moving to the right is eventually they're going to move off this table. We don't want that. So we want the E in E23 to remain fixed. So that's the E just there. And the same applies to the F in F23 and the G in G23 and the H in H23. We don't want those letters to change as we copy this across to the right. Now, do we want the numbers in these to change as we copy this down? Yes. When we copy this formula down 1 row, so we've got the mild state, we want all these 4 to move down 1, so they're also referencing the mild state as the next state. So this looks good to me. I've got dollar symbols between before the 40, the 41, the 42, the 43, and I have a dollar symbol before the E, the F, the G, and the H. So I'm going to press enter. And not surprisingly, that's going to go to 0.91 in cycle 2 because we started with 100 patients, I should say 100% of the patients here. And it's copied this across and down and it's happy with it. This is the right value and it's copied correctly. So step 2.5 is now complete. Now here we've got to do a similar validity check than we did before. And what we could do is just select this cell here. If you recall, we're doing a sum across these 4. We need to do exactly the same thing here. Make sure that these sum to 1. So I'm going to select this. I'm going to right click and copy. And then instead of just doing a paste, which would also paste the green formatting, which I hope it does get colored green, but it's cheating a little bit. I'm going to right click, go to paste special, formula only. So that's the right formula, but whether or not it gets colored green depends on the automated marking system. And yes, it's happy with it. It copies across properly. Step 2.6 is now completed. Now in step 2.7, we are going to do the costs for each state. So the first thing we need to do is the cost of being in the asymptomatic state in each cycle. So there's a few things we need to think about here. So the first is what proportion of the cohort is actually in the asymptomatic state. So right now in cycle 1, 100% are, but in later cycles, there's going to be a smaller proportion of the cohort in the asymptomatic state. And that's going to mean that there's smaller costs, right, in the asymptomatic state. So the first thing we do is we say equals, and we need the proportion of the cohort that's in the asymptomatic state. So that's D40. And we don't want to lock this. We don't want to lock the D. We want, as we copy this across, we want that D40 to change to E40, F40, and so on. Okay, so that's how we begin. And then we need to think, well, what are the costs that are incurred when a patient is in the asymptomatic state and they are receiving treatment A? So we need to multiply that by, and I'm going to open a bracket. And the first cost is the cost of treatment A itself. And if we look on the left of the screen, you can see under the hint in row 228, the name C_TX has been assigned to the cell on the input sheet with the cost for treatment A. So that's a bit of a shortcut. I'm just going to do C_, and you can see here a list of various different costs we've got on the input sheet. I'm going to just click on C_TXA. And then what's the other cost? The other cost is the other healthcare cost for being in the asymptomatic state. So we're going to add, and I'm going to do the C_ again. And I would like the C_asymp cell. So inputs 8024. There we go. And then I need to close the bracket. So what this is going to do is going to take the cost of treatment A, add it to the cost of being in the asymptomatic state, and then it's going to weight this by the proportion of the cohort that's in the asymptomatic state. So right now I'm going to press enter, and it's going to be $2,800 in the first cycle, and that's because treatment A costs $2,000, and being in the asymptomatic state costs $800. So, and because everyone is in the asymptomatic state, it doesn't get weighted, right? It just gets multiplied by 1. So it's exactly 2,800. When we get into later cycles, you can see that that's falling. And that's because we've got less than all of the cohort in the asymptomatic state. Okay, the next one is mild. So we're going to begin in the same way, equals, and this time we want the proportion of the cohort in the mild state. Now, in cycle 1, that's 0, but in cycle 2, 3, 4, and so on, there's going to be patients in this state. So we're going to multiply that by, open a bracket, And what do we want now? We still want the cost of treatment A. So start with a C, and we can see that there is C underscore TXA. And then this time we need the cost of being in the mild state, not the asymptomatic state. So that's this one. Oh, sorry. No, it's not. It's this one. Okay, so we've got the cost of treatment A plus the cost of the mild state, and I need to close the bracket now. And I'm going to press enter. Okay, so that's correct, and it's been copied across correctly. And if you failed to weight it by the proportion, what you might find is, well, this will give you the incorrect answer. For the previous step with the asymptomatic, if you don't weight it by D40, this value would be correct, but when you copy it across, it would be incorrect. So let's move on to severe now. Now, we need to be careful because look at hint 2 on the left. Patients receive the treatment only in the asymptomatic and mild states. So we don't need the cost of treatment in the severe state. So we're going to use the weight again. So we weight it by the proportion in the severe state in D42. And this time we just need to multiply it by the cost of being in the severe state. There we go, and press enter. Okay, and then finally, there's the cost of being in the dead state. And we didn't enter anything on the input sheet for this because it is free to be dead. There are no further costs when you're dead. So we just hard code that as 0, press enter. Okay, and now we need the aggregated costs. In step 2.11, calculate the aggregated costs for treatment A. And to do this, we just have to sum the costs over all 4 of these states. So we're going to enter a formula here, equals sum. We just need all 4 of these. So 2,800. So nice round number in cycle 1, but it's going to be not round in the future cycles. And the reason being that we have these different proportions of patients across the different states. Okay, so now a few more rows have appeared. We need to calculate the QALYs for treatment A. And I'll let you read the instructions on the left here. So what do we need to think about here? One important thing is, well, the first important thing is the utility weight, that health utility. So if you recall, it was 0.85 in the asymptomatic state. So we need that. The other thing we need to think about is that the cycle length is 1 month. So there are 12 cycles in a year. Now, if you were to just multiply the proportion of patients by the utility weight, you would be overestimating the QALYs in that first month. You'd actually be calculating the QALYs for an entire year. We don't want that. We just want the QALYs for a month. So what we need to do is we need to, first of all, start with an equals, and we'll start with the proportion in D40. So the proportion of the cohort that are in the asymptomatic state. And then we're going to multiply this by, I'm going to open the bracket. And we need the utility weight for being in the asymptomatic state, that health utility. And it says on the left in 266, row 266, the name U asymp has been assigned. Okay, so U, and then we've got, there's various different functions that are being recommended here, but what I want is this U asymp. And we need to divide this by the number of cycles in a year. So in this particular model, we know that's 12. But in principle, we might change that, right? In principle, that can be changed. So it's good practice to not hard code 12. It's good practice to use the cycles per year. So if you start with the S and then do an underscore, you can see that there are various different settings here, and we need S cycles per year. And then we'll close the bracket. Okay, so that's correct. And we're going to move on to the next step now, step 2.13. We need to do the same thing for the miles state. And it's going to look very, very similar to this, except that, of course, it's not D40 that we need now. We need to reference D41. And we're going to multiply it by, and I'll open the brackets, although I don't think that's strictly necessary. We need to multiply it by the utility for the mild state. So U underscore, and then we've got mild at the top here. And then we need to divide that by the cycles per year. There we go. So S cycles per year, and then we'll close the bracket. And then for the severe state, it's a similar thing. We reference the proportion, the severe state. We multiply that by, first of all, the utility weight. And now we need the utility for severe, and then divide that by cycles per year. And then we'll close the bracket. And then finally, the qualities that you get in the dead state are 0. Right? We didn't enter a health utility on the settings, on the input sheet. We just hard code this as 0. And then we have to calculate the aggregated quality. So very, very much like the aggregated costs. In fact, what we can do here is just copy that formula, and don't just do a regular paste, because not only will it copy over the green formatting, which we don't want, it will also copy over the dollar formatting, the currency formatting. We don't want that either. So make sure you do paste special formula only. And what it's copying over is that sum of those 4 cells. Okay, so that's 2.16 completed, and that's the end of task 2. In task 3, we're going to do exactly the same thing again, but for treatment B rather than treatment A. So I'll see you in the next video.